Hi, I'm Sean Gannon, and this is Minute Math. And we have the two circles, one triangle puzzle here. This nice geometry puzzle. Let me give you some information about our picture. We have two identical circles here that are touching at point D, and they have, well, a radius of 1. From there, we create this triangle ABC on the inside. But if we continue the lines out, they're created from T and R being points of tangency on each of the circle. With just this information, we want to find the area of this inner triangle ABC. This one takes some extra thinking here, so pause this video, really try to see if you can solve it and remember your geometry. But as always here, I'm going to show you a way to solve this problem. Okay? So the first thing I like to do here is I am going to draw a line from R to N. So I connect R to N, and what I'm doing could be flipped to the other side, but for right now I'm just doing R to N. Line to R, N right here. We draw a line RN, and we know that the angle ARN is a right angle because this point R is a point of tangency, and our laws tell us that if we have a tangent line connected to the radius here, that point is going to be a right angle. So what do we know about, well, this new triangle that we created, ARN? Well, we know some side lengths here. A to N has a side length of 1, 2, 3. And we know that NR is equal to, well, 1. Right there. So we have a right triangle where we have two side lengths that are given to us. From there, we can, well, use Pythagorean theorem to find out the length of AR. So AR is one of the legs of the triangle. So we have 1 squared plus AR squared. Let's just call it, let's do AR squared like this. Is equal to a C squared, the hypotenuse, 1, 2, 3, 3 squared. All right. From there, we're simplifying. All right, we have 1 plus AR squared equals 3 squared, which is 9. Subtract 1 to both sides, AR squared equals 8. Square root that bad boy, and AR is equal to the square root of 8, which comes out to be 2 square root of 2. So that length here, we can write it as 2 square root of 2 for AR. Well, now I want to actually draw another triangle, okay? And the name of the game here is trying to find two similar triangles, give you a little foreshadow. I'm going to draw a line from C to D. So it's a perpendicular line, or perpendicular line from D up, straight through, perpendicular here to line AB. And we have a little, let's connect it to this point. We don't need to draw past it if we don't need to. What do we know about this triangle? Well, I'm drawing perpendicularly, so it's a right triangle, and it goes through point C. So we have two right triangles here. Can we show if they are, well, similar? Okay. Well, we can. We know they both have a right angle, and they both share angle here, CAD. Let's call that alpha. Okay. If that angle is alpha, all right, and we call it, say, the other angle on the inside, let's call that one beta on the inside here, then this angle also must be beta. How so? Right angle. So these two angles, so both are right angle, the other two angles within each triangle have to add up to be 90 degrees. So if they both share alpha, that means these both must be beta. And this actually helps us here create similar triangles. This is a good technique. So we're gonna say the triangle here, let's go in order. So let's go the big one first, ARN. ARN is similar, okay, similar, sharing alpha, let's go to legs, ADB. Triangle ADB, okay? By the angle, and you only need two, but angle theorem if you want to go that way. ARN is similar to ADB, okay? These triangles are similar, meaning that their side lengths are proportionate. So now let's go set a proportion up. Let's do the long leg over the short leg for each triangle. So I'm going to say AD over CD is equal to the proportion the long leg AR over RN. And let's fill in the values that we know. Well, AD has a, value of 2. So we have 2 over CD, which we don't know. Let's call that H, our height for the triangle. Let's make it easier. Then AR, we do know, which is 2 square root 2, over RN, which is 1. And then from there, we want to go solve for H. So we cross multiply. This kind of transitions here, cross multiplying up and up. We have 2 equals H times 2 square root 2. Divide both sides by 2 square root 2. I think you can do that part here. And we have, H is equal to 1 over square root of 2. Okay, or simplifying out, that's a square root of 2 over 2, multiplied by square root 2 over square root 2. So we have our height here, which is square root 2 over 2, all right? And now we have enough information really to find the area of our whole triangle. We have a base 1, 2, 3, 4, and a height of square root 2 over 2. We can find that area. So let's make a little line here. So area equals 1/2 base times height. 1/2 base is 4, times height is square root of 2 over 2. This simplifies pretty easily. 2 and a 4 here, we're going with 2 in the numerator, 2 here cancel out. And we're left with a square root of 2 units squared. And after all that, the area of this inner triangle that we found is a square root 2 units squared. Is that the answer you got? Is this the method that you used to solve this problem? Let me know down in the comment section below. Don't forget to share this video with your friends, see if they can solve this problem. And subscribe to our YouTube channel, like this video. It helps us make more of this stuff. Anyway, you know the drill. As always here, thanks for watching.